My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 444. In this lecture, we will try to understand graph data and featurization. Another very popular form of data is called graph based data. Let me take an example to explain this because again as usual featurizations in data is very problem specific. Imagine if I have a graph like this where each vertex or node is like this. User U1 who is connected to user U2. U2 is also connected to U4. U1 is connected to U3. Let's say U2 is a friend of U5. U4 is also a friend of U5. Isn't it? Each user represents a vertex, users are vertices, and friendship is edge. And this is called social graph. Facebook have largest social graph with billions of users. Just see here, if there is an edge, direct edge, what does it mean? They have friendship, isn't it? Yes, let's say this is the data I am given. Now let's take up a task. Our task is to recommend new friends for user UI. Let me say we are interested in identifying friends for UI. So, given a user UI, our task is to recommend friends for user UI. How do we do it? This is the task, which is the machine learning problem, business problem that we want to solve. So, this is the data we are given. One way to pose this problem, not the best way certainly, given UI and U1, if they are already friends, put a value 1. If they are not friends, what you have to do? Put a value of 0. So you will do this for all the users. Now you want to recommend friends for UI, isn't it? Let's take a concrete example. Let's assume in this graph you want to recommend friends for user U4. Let's just apply common sense. When we have to recommend friends for U4, you look at mutual friends. U1 and U4 are already friends. U2, U4 are also friends. U7 and U4 are not yet friends, isn't it? U7 and U4 are not yet friends. They could be friends. So I have to predict the probability that U7 and U4 are friends. U3 and U4, there is no edge. U3, U4 could also be connected. When you are recommending friends for U4, you can recommend U7 and U3. For rest of them, U4 is connected. U4 is connected with U1, U4 is connected with U2, U4 is connected with U5, U4 is connected with U6. Now, you have to predict whether there is a good chance U7 and U4 are being friends, or there is a good chance of U3 and U4 are being friends. Now, let's just apply common sense because we know how people make friendships. Let's look at the common friends between U7 and U4. Isn't it? There is only one common friend. There is only one common friend, that is U1. How many common friends exists between U3 and U4? Between U3 and U4, just see, between U7 and U4, there is one common friend. Between U3 and U4, there are two common friends, u1 and u2. If I create a feature f1 which is number of mutual friends, we know that more the number of mutual friends, higher is the mutual friends, higher is the chance that a pair could be friends. So we can actually use number of mutual friends as a feature. The second more interesting feature could be f2, number of paths. f2 is number of paths between u3 and u4. Path basically means how many ways can I reach from u4 to u3, isn't it? So of course I can reach from u4 to u3. I can reach from u4 to u3 via u2. This is one path, isn't it? I can reach it via u1 also, isn't it? u1 path is basically sequence of edges. That could be single edge also, isn't it? So more the number of paths, I can go from u4 to u3 with path of length 2. Let's assume length of each edge is 1. Again, there is a huge area of graph theory, and in graph theory there are tons of algorithms, tons of featureizations, tons of methods to measure how far from one vertex to other vertex you can count the number of paths. For example, in this graph I have a path from u4 to u3 while going through u5 is also a path. Just see, isn't it? I can go from u4 to u3 through u5, isn't it? If there are more paths, then there is a higher chance of that both of them being friends. So you can design features like this, which are called graph theoretical features, graph based features. To compute these features, what do? You apply graph theoretical algorithms, isn't it? Graph theory, image processing, signal processing, relational features, all these are problem specific. We have case study of predicting friends on Facebook graph, where we will explore more graph based features as and when needed. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.